Mm, Good afternoon, students. Myself Srinivas Rao. Today I am giving presentation on regression techniques and KNN classifiers for CO4. So the aim of the session to introduce students to the linear regression and to familiarize students with the logic regression. So the instructional objectives is introduce linear regression, demonstrate components of polynomial regression, describe the examples of linear regression and logistic regression, demonstrate about KNN algorithms, describe about k-means algorithm, understand KNN and k-means with worked out examples. At the end of the learning outcomes, this topic, define the linear regression, summarize the techniques used for prediction as linear and logistic and polynomial regression, compare and contrast among linear and logistic and polynomial regression methods. So first of all, we have to discuss linear regression. What is linear regression? So here here in this unit, linear regression and KNN classifiers. First, what is linear regression? The linear regression is to predict the model's continuous valued functions, that is predicts unknown or missing values. So prediction in case of numerical data is similar to classification. So the classification is construct. How can we classification? We have done construct a model, use a model to predict continuous or ordered value for a given input. Prediction in case of categorical data is different from classification. Classification refers to predicting the categorical or class label. The major method for prediction is regression. The relationship between one or more independent or predictor variables and a dependent or response variable. Regression analysis can be categorized as three types. They are linear regression and multiple regression, non-linear regression, other regression methods, generalized linear model, Poisson regression, log linear models, regression trees. So regression. So in regression, the output is continuous. Many models could be used simplest in linear regression. Fit data with the best hyperplane which goes through the points. So here the x-axis, y-axis are there. So here independent variable, that is input, y is the dependent variable, that is output. So this is the regression will be done this the way. A simple example, fitting a polynomial. The green curve is the given diagrams. The green curve is the true function which is not a polynomial, and we may use a loss function that measures the squared error in the prediction of y of x from x. Regression model types. Here the regression models are classified as feature and features. So simple features, simple regression models, and multi features, multiple regression models. So simple is linear and non-linear, and again multiple regression models also classified linear and non-linear. This is the regression model types. Simple linear regression equation. Here the simple linear regression is, so intercept and x and y axis, so x axis and the slope and regression line. So this is the prediction of the regression line. Linear regression model. The relationship between variables is a linear function. So here the yi is equal to beta naught plus beta 1 xi plus summation sigma I. So here the yi is the dependent variable, beta naught is the population of y-intercept, and beta 1 is the population slope coefficient, and xi is the independent variable, and this is the random error term. So the beta naught and beta naught plus b1 xi is equal to linear component, and sigma I is the random error component. The linear regression involves a response variable y and a single predictor variable x, that is equal to y is equal to w naught plus w1 x, where w naught y-intercept and w1 is slope of the regression are coefficients. Method of least squares. Estimate the best fitting straight line. W1 is equal to sigma I is equal to 1 to d mod d of xi minus x bar into yi minus y bar by sigma I is equal to d modulus of xi minus x bar whole square. So here the multiple linear regression involves more than one predictor variable. Training data is of the form of x1, y1, x2, y2 and so on x modulus of d, y modulus of d. Example, for 2D data, we may have y is equal to w0 plus w1 x1 plus w2 x2, solvable by extension of the least square method or using SAS, that is statistical analysis system, S plus. Many nonlinear functions can be transformed into the above. Some nonlinear models can be modeled by a polynomial function. A polynomial regression model can be transformed into a linear regression model. For example, y is equal to w0 plus w1 x plus w2 x2 plus w3 x cube. So convertible to linear with new variables, x2 is equal to x square, x3 is equal to x cube. So y is equal to w plus w1 x plus w2 x2 plus w3 x3. Other functions such as the power functions can also be transformed into a linear model. Some models are intractable nonlinear. Example, sum of exponential terms. Possible to obtain least square estimates through extensive calculations on more complex formula. Advantage of linear regression. Linear regression performs well when the data set is linearly separable. It can be used to find the nature of the relationship among the variables. It is easier to implement and interpret and very efficient to train. Even though it is prone to overfitting, it can be easily avoided using some dimensionality reduction techniques, regularization, that is called L1 and L2 regularization techniques, and cross validation. Disadvantage of linear regression. Major limitation is the assumption of linearity between the dependent variable and the independent variables, because in the real world the data are rarely linearly separable. It assumes that there is a straight line relationship between the dependent and independent variables, which is incorrect many times. Prone to noise and overfitting. If the number of observations is lesser than the number of features, linear regression should not be used. Otherwise, it may lead to overfitting because it starts considering noise in this scenario while building the model. The another disadvantage of linear regression is prone to outliers. It is very sensitive to outliers, so outliers should be analyzed and removed before applying linear regression to the data set. Prone to multicollinearity. Before applying linear regression, multicollinearity should be removed because it assumes that there is no relationship among independent variables. And another regression technique is logistic regression. The logistic regression model yields the probability approximation rather than predictions. It is an extension of the linear regression model for classification problems. This model is suitable for a binary classification problem. And in this model, the probability of any event taking place is treated as a linear function of a set of input features. Instead of fitting a straight line or hyperplane, the logistic regression model uses the logistic function to squeeze the output of a linear equation between 0 and 1. Thus, the logic regression model estimates P for a linear combination of independent variables to determine the actual class label. What is wrong with linear regression for classification? So here the given diagram is threshold value and the threshold 0.5, and next we can say threshold. So here the linear regression model can work well for regression but fails for classification. Why? In the case of two classes, you could label one of the classes with 0 and the other with 1 and use linear regression. Linear models do not extend to classification problems with multiple classes. From the figure, the given figure, a linear model classifies tumors as a malignant or begin 0 given their size. The lines show the prediction of the linear model. For the data on the left, we can use 0.5 as the classification threshold. So here we can consider as a threshold value of the 0.5. After introducing a few more malignant tumor cases, the regression line shifts and a threshold of 0.5 is no longer separates the classes. Points are slightly jittered to reduce overplotting. So here we can observe a small difference is there. So the logistic regression. Logistic regression is similar to linear regression, but it uses the traditional regression formula inside the logistic function of e cap of x by 1 plus e cap of x. As a result, this logistic function creates a different way of interpreting coefficients. So here the the logistic function is e of beta naught plus beta 1 x by 1 plus e power beta naught plus beta 1 x. So sigmoid function, it is a S-shaped graph, and mathematically it is defined as sigmoid of x is equal to e power x by 1 plus e power x is equal to 1 by 1 plus e power minus x. So here here the sigmoid function is calculated in the given mathematical function, that is called here the x-axis and y-axis, here the sigmoid function. Then next, maximum likelihood estimation is calculated for the regression coefficient. Limitations of logistic regression. Logistic regression is a simple and powerful linear classification algorithm. It also has limitations that suggest the need for alternate linear classification algorithms. Here two class problems. Logistic regression is intended for two class or binary classification problems. It can be extended for multi-class classification but is rarely used for this purpose. Unstable with well separated classes. Logistic regression can become unstable when the classes are well separated. So here the logistic regression can suffer from complete separation. If there is a feature that would perfectly separate the two classes, the logistic regression model can no longer be trained. This is because the weight for that feature would not converge because the optimal weight would be infinite. Unstable with few examples. Logistic regression can become unstable when there are few examples from which to estimate the parameters. Here we can observe one small note. An unstable model refers to the spectrum from poor results to a model that may not reliably converge on a set of coefficients. So here the logistic regression model finds the correct decision boundary between malignant and begin depending on tumor size. The line is the logistic function shifted and squeezed to fit the data. Here we can observe that. Next, linear regression versus logistic regression. So here the linear regression, can you see a simple linear model and a polynomial model. A simple, here the models can be having x-axis, y-axis, and the curve you can show. You can see simple linear model is y is equal to b naught plus b1x. So this is the regression. So these are the data points. The green color indicates the data points. This red color line indicates the regression line. So here the polynomial model, say the curve will be displaying. So here the green points are representing as data points, and the equations will be called as y is equal to b naught plus b1x1 plus b2x1 whole square. So this is the differentiate between linear regression and versus logistic regression. Next, KNN classifiers. So here the KNN stands for K nearest neighbor classifiers. So we can call a shortcut of KNN classifiers. The K nearest neighbor is one of the simplest machine learning algorithms based on supervised learning technique. The KNN algorithm assumes the similarity between the new case data and available cases and put the new case into the category that is most similar to the available categories. The KNN algorithm can be used for regression as well as for classification, but mostly it is used for the classification problems. KNN is a non-parametric algorithm, which means it does not make any assumption on underlying data. It is also called a lazy learner algorithm. So KNN algorithm at the training phase just stores the data set, and when it gets new data, then it classifies the data into a category that is much similar to the new data. Simple example of KNN classification. Suppose we have an image of a image of a creature that looks similar to cat and dog, but we want to know either it is a cat or dog. So for this identification, we can use the KNN algorithm as it works on a similarity measure. Our KNN model will find the similar features of the new data set to the cats and dogs images, and based on the most similar features, it will put into in either cat or dog category. So here we can see the input value cat, the predicted output also cat, but the KNN classifier. So we will give the two images cat and dog, and then we can classify the images. Need for the KNN algorithm. Suppose there are two categories, that is category A and category B, and we have a new data point. So this data point will lie in which of these categories. To solve this type of problem, we need a KNN algorithm. With the help of KNN, we can easily identify the category or class of a particular data set. Consider the below diagram. So, before KNN, after KNN. So, here category A and category A. So, here we can use category B, new data point, and KNN. So, the green color indicates the category A and orange color indicates the category B and the blue color indicates the new data point. Like in after this is the before KNN. After we are applying KNN classification algorithm, so the category of data points are representing green color and category B of data points are representing orange color, and whatever we are predicting the after applying the KNN algorithm, the new data point assigned to category 1, that is also category of that is indicates but green color. How does KNN work? Select the step 1, select the number k of the neighbors and calculate the step 2, calculate the Euclidean distance of k number of neighbors. Step 3, take the k nearest neighbors as per the calculated Euclidean distance. Step 4, among these k neighbors, count the number of the data points in each category. Step 5, assign the new data points to that category for which the number of the neighbors is maximum. And step 6, our model is ready. So, these are the steps involved in we are working on KNN. For example, suppose we have a new data point and we need to put it in the required category. Consider the below image. So, here the given image, category A, category B and new data point that indicates orange color. So, the category A data points are indicated as green color, category B data points are indicated as blue color and the new data point is indicated orange color. Here x1 is indicates x axis and x2 is the y axis. So, example, firstly we will choose the number of neighbors, so we will choose the k is equal to 5. Next we will calculate the Euclidean distance between the data points. The Euclidean distance is the distance between 2 points which we have already studied in geometry. It can be calculated as the below equation. By calculating the Euclidean distance, we got the nearest neighbors as 3 nearest neighbors in category A and 2 nearest neighbors in category B. Consider the below image. Here the given image is category A, category B and the new point. The category A is the 3 neighbors, category B is the 2 neighbors. As we can see the 3 nearest neighbors are from category A, hence this new data point must belong to category A. How to select the value of k in the KNN algorithm? Below are some points to remember while selecting the k value in the in the KNN algorithm. There is no particular way to determine the best value for k. So, we need to try some values to find the best out of them. The most preferred value for k is 5. A very low value for k, such as k is equal to 1 or k is equal to 2, can be noisy and lead to the effects of outliers in the model. Large values for k are good, but it may find some difficulties. Advantage and disadvantage of KNN algorithm. So, advantage: it is simple to implement, it is robust to the noisy training data, it can be more effective if the training data is large. And disadvantage: always need to determine the value of k, which may be complex sometime. The computation cost is high because of calculating the distance between the data points for all the training samples. The k-means clustering. It is an iterative algorithm that divides the unlabeled data set into k different clusters in such a way that each data set belongs only one group that has similar properties. The k-means clustering is an unsupervised learning algorithm which groups the unlabeled data set into different clusters. Here k defines the number of predefined clusters that need to be created in the process. As if k is equal to, there will be 2 clusters, and for k is equal to 3 there will be 3 clusters, and so on. And next continuation, the k-means clustering algorithm mainly performs 2 tasks. First one determines the best value for k center points or centroids by an iterative process, assigns each data point to its closest k center. Those data points which are near to the particular k center create a cluster. So, here we can see before k means, so here we can get 3 types of category. All the data points are same and we can applying k-means. After that we can categorize different data points, green, blue and black. So here we can clustering the data points. How does the k-means algorithm work? The working of the k-means algorithm is explained in the below steps. The step 1, select the number k to decide the number of clusters, and step 2, select random k points or centroids. It can be other from the input data set. And step 3, assign each data point to their closest centroid, which will form the predefined k clusters. And step 4, calculate the variance and place a new centroid of each cluster. And step 5, repeat the third steps, which means reassign each data point to the new closest centroid of each cluster. Step 6, if any reassignment occurs, then go to step 4, else go to finish. And step 7, the last and final step, step 7, the model is ready. So these are the steps involved in k-means clustering algorithm. As example, suppose we have two variables m1 and m2. The xy axis scatter plot of these two variables is given below. Let's take some number k of clusters, that is k is equal to identify the data set and to put them into different clusters. It means here we will try to group these data sets into two different clusters. We need to choose some random k points or centroid from the cluster. These points can be either the points from the data set or any other point. So we are selecting the below 2 points as k points which are not the part of our data set. Consider the below image. So these are the examples, and as we need to find the closest cluster, so we will repeat the process by choosing a new centroid. To choose the new centroids, we will compute the center of gravity of these centroids, and we will find new centroids as below. So we can see the examples. Next we will reassign each data point to the new centroid. For this we will repeat the same process to finding a median line. The median line will be like below image. This is the median line. These are the examples, how the data points are reassigned and how the data points are clustering. As our model is ready, so we can now remove the assumed centroids, and the two final clusters will be as shown in the below image. So here we can see two clusters. One cluster is blue, the other cluster is orange. The summary of this, the simple linear regression equation is, so here the equations, and multiple linear regression equation like this, and polynomial regression equation and logistic regression. So these are the equations. We can summarize the this outcome. Attributes, selection measures and decision tree, information gain ratio and Gini index. The next is the self-assessment questions and terminal questions. So these are the terminal questions. Explain the difference between simple linear regression and multiple linear regression. When would you choose one over the other? Explain the linear regression with an example. List different types of regression techniques. Differentiate between classification and prediction. These are the references. Thank you.